Hi everyone, I'm Xinye Li.
Hello everyone, I'm Soyan Shin.
I'm Taeop Kim from Group 23. We're very excited to present our project to all of you. Since like a few years ago, Amazon became an e-commerce giant that is now valued at over $880 billion. Countless number of people shop on Amazon.com every day, and along with many other features, there is one feature that helped Amazon to retain their customers. This feature is not only used at Amazon, but it's also used at various other places as well. The feature is called the recommender system. It allows the provider to recommend other items that the customers are likely going to be interested in based on their browsing and/or purchasing history. So naturally, since the provider provides relevant and useful recommendations, customers are more likely to come back to that provider compared to other places. So our group decided to dig more into it. We have researched a few other papers to see other works, learn how to design our own recommender system, and finally implement our own. So in short, our recommender system uses a hybrid approach using two different methods. The first one is called the collaborative filtering, and second one is called the content-based recommendations. So first, Soyeon will explain to you guys about collaborative filtering in more detail.
Now I'll be explaining about what collaborative filtering is. Collaborative filtering is the process of filtering and recommending items using the past behaviors of users. Let's look at a simplified example. Here we have a table containing the individual ratings of each item by the four users Amy, Bob, Cindy, and David. This is called the user item matrix. Let's say we want to figure out whether we should recommend books to Cindy. First, let's compare the ratings of users that are similar to Cindy. Cindy gave low ratings to cameras and shoes. Similarly, Amy and Bob also gave low ratings to cameras and shoes. Also, note that Amy and Bob gave high ratings to books. Now we can infer based on the past ratings of Amy and Bob that it's quite likely that Cindy will also like books. Among many collaborative filtering algorithms, we used alternating least squares, which uses matrix factorization. Given the input matrix containing the known ratings, the alternating least squares algorithm, in short ALS, factorizes the given matrix into two factors, the user factor matrix and the item factor matrix. In the process, it alternates between holding the user factor matrix constant and optimizing the item factor matrix, and holding the item factor matrix constant and optimizing the user factor matrix. To implement the ALS algorithm, we used the PySpark library. And in order to train the best model, we used hyperparameter tuning along with five-fold verification. To find the best hyperparameters, we tried different values for the maximum number of iterations, the rank of the user factor and item factor matrices, and the regularization parameter lambda. This way, we could find the values that gave the minimum loss for our dataset. Next, in the five-fold verification step, we split the input data into 5 parts and used one out of the 5 parts as the validation or test set, and the rest as the training set. This was repeated 5 times for each of the 5 parts. Then, the average loss was calculated. Using these steps, we built our final model with minimized error.
Now move on to content-based filtering. It is a recommendation strategy which uses content attributes to calculate the similarity, then provides recommendations. To find the similarity among items, we use term frequency, inverse document frequency, aka TF-IDF, which is a way to determine the relative significance of each word of a document. TF-IDF can be calculated by multiplying two matrices, TF and IDF. TF, which is term frequency, the frequency of word occurrence in a document. If TF is high, it means a term is important since it appears frequently in a document. IDF, which is inverse document frequency, it determines whether the term is rare or common in the set of documents. If IDF is low, it means a term cannot be an unique identifier since it appears in many documents. For example, we have a folder of files and each file introduces a city of Canada. In Waterloo.txt, the of beautiful Waterloo may have a high TF since they occur frequently in Waterloo.txt. but the of may have a low IDF since they may also occur frequently in many other files. However, beautiful may occur not very often, and Waterloo will be even rare, so Waterloo will have a higher IDF than beautiful. After applying TF-IDF, we then use the cosine similarity to find items with high value. The advantage of content-based filtering is that it does not suffer the cold start problem, since it does not rely on user rates. And the disadvantage is that not all movies from the same genre are equally good.
During this COVID-19 pandemic, many people stay inside at home, and probably the only 100% safe way to interact with the outside world would be through the internet. So we believe that the recommender system, which is useful for both new customers and returning customers, would be of great influence to many people, as it allows customers to have personalized experiences in many different fields. Not only can it be used for e-commerce purposes, but it can also be expanded out to be used for recommending movies, songs, books, games, and much more. So we hope that our presentation regarding recommender systems provided you with some new information, so that next time you go onto Amazon.com and see the recommendation list, you'll know exactly where that came from. Thank you very much.